Composition of functions is important in first semester calculus because we can use the slopes of component functions f and g to compute the slope of the composite function f of g of x. This example here, f of x is 1 over x minus 4, g of x is 1 over x minus 1, and we want to compute the composite function. I've written composition two different ways, and it's these are both notations that are used. F a circle dot here. G is f composed with g of x. It means the same thing as f of g of x. So I'm going to rewrite this as f of g of x, and then the output from g becomes the input for f. So in the formula for f of x, wherever you see an x, you want to put g of x. So instead of 1 over x minus 4, we're going to have 1 over g of x minus 4. And then we can replace g of x by its formula, this 1 over x minus 1 minus 4. And now it's a matter of simplifying it. We have a fraction within the fraction. We can multiply each term by the inside denominator to simplify that. So it's 1 times x minus 1 over 1 over x minus 1 times x minus 1 minus 4 times x minus 1. Okay, so we can distribute the 1 here, cancel the x minus 1's there, distribute the negative 4, and this will give us x minus 1 over 1 minus 4x plus 4. And then if we combine like terms, 1 plus 4 is 5, so it's x minus 1 over 5 minus 4x. And the domain of x such that, well, we can't get past this step here if x is 1, because we can't have denominator 0. So x is not equal to 1. And then the final answer, x cannot be 5/4. We're trying to avoid denominator 0. So x cannot be 5/4. Okay? And so those are the two numbers that are not in the domain. Otherwise, x can be any real number. We could also compose f with itself. So this is f of x. So the output for f becomes the input for f. So in the formula for f of x, here's f of x again. Instead of x minus 4, we're going to have f of x minus 4. So this is going to be 1 over f of x minus 4. And then replace f of x by 1 over x minus 4. So this is 1 over x minus 4 minus 4. And then we have a fraction within a fraction, so we want to simplify that by multiplying by the inside denominator. Multiply each term by the inside denominator. So it's 1 times x minus 4 over 1 over x minus 4 times x minus 4 minus 4 times x minus 4. And then we can distribute the 1 on top, cancel the x minus 4's here, distribute the negative 4, and that'll give us x minus 4 over 1 minus 4x plus 16. And then if we combine like terms, we'll have x minus 4 over 17 minus 4x. The main of x such that x is not equal to 4. We can't get past this step here if x is 4, because that gives us denominator 0, and also x cannot be 17/4, because in the final answer, if x is 17/4, we'll have denominator 0 there. Okay. Now usually we'll be working with functions that have formulas, but the same principle can apply if a function is just a finite set of points. So f is the set of 3 points, 1, 1, 2, 3, 3, 2. The first coordinate would be the input. The second coordinate is the output. For the function g, we also have 3 points, 1, 3, 2, 1, 3, 2. So so we want f composed with g. So the output for g becomes the input for f. So we want to apply the function g first. The function g, when the input is 1, the output is 3, right? When the input is 2, the output is 1. And when the input is 3, the output is 2. And then we apply the function f. For the function f, when the input is 3, the output is 2. When the input is 1, the output is 1. And when the input is 2, the output is 3. The composition then, the original input with the final output. So we'll have 1, 2, 2, 1, and 3, 3. That's the composite function. Again, we will usually be using formulas with functions, but you can also apply the same sort of basic idea to a graph. F of g of 0, f composed with g of 0, and we want to use the graph. So the output for g becomes the input for f. So we want to look at g of 0, and go to 0 on the x-axis, and the g coordinate looks like it's -1. So g of 0 looks like it's -1. So then we want to do f of -1. So if we go to -1 and go up to where it crosses the function f, it looks like it's about 2. So that's f of g of 0 looks like it's about 2. G of f of 0, now f is the output for f becomes the input for g now. So g of f of 0. So now we want to do f of 0, which is 1. Go to 0 on the x-axis and go up to where it meets the curve f of x. It looks like it's about 1. So this is g of 1, and g of 1, go to 1 on the x-axis, go down to where the g curve, and it looks like about -1/2. So this is about -1/2. And that concludes this presentation.